guess when you run into that, make an assumption, run with it, and move on to the next problem. I know that's tough, but it's stuff that you have to do, you know, sometimes in the real world too. Although if you want to, they have contact information on, the publishers like to hear that type of stuff and pick that up. So feel free to send that. Did you already do it? Okay, yeah. Send that stuff to them, seriously. And they do make changes. I've talked to this author myself on setting up some of the stuff, and they do want to hear that stuff.
Yeah, because
sometimes it's hard to catch.
I was earning $10, $20, but in this question, I'm like.
Right. So for this class, I won't promise I'm going to give you extra credit points, but if I see a nicely, whatever your assumption was laid out, that's all I want to see. You got the answer right. If there's something that's not clear, you're doing good in this class. That's exactly what I want to see you do. Okay, any other problems to review? Yep, which one? Just to the top question. Okay. Anything else? All right, shall we move on to tonight's additional fun? All right, so chapter 6, we need to get some basics down on demand. As I mentioned before, the textbook does sometimes assume that you guys have some information at your disposal, which you might have to search for. Luckily, there's plenty of resources. By the way, one I might mention that is very robust with a number of different topics. Have you guys ever gone to Khan Academy?
Yes.
K-A-H-N Academy. So you might want to write that down. He's got a bunch of very simplistic, work you through a problem, and he's been doing this for years now. And so if we're talking about a concept in class, or you read something in our book, and it seems like the author's making an assumption that I know something about something that I'm not sure I really know, and you put law of demand, go to Khan Academy, and they'll give a quick little tutorial of what the law of demand is. So that might be a resource that has, and that's all on YouTube, and he draws graphs with a computer and does a bunch of stuff. So there's a lot of principles of microeconomics is really what most of this is drawing from. Okay, so the law of demand. Does anybody want to take a stab at the law of demand? The law of demand has something to do with price and quantity.
When
Price goes up, quantity goes down, right, for the demand side of life. So in our market system, if we're thinking about the output market, and remember we have two different markets. I guess I don't have my quick little sheet to pull out. The output market and the resource market. In the output market, we've got consumers that are trying to make themselves as happy as possible, and they will tend to buy more. So as the price of a good or service, G or S, as the price of a good or service increases, the quantity demanded, I want to come back to this here, so write down exactly what I'm writing here. The quantity demanded decreases. All right, so in shorthand notation, an increase in price leads to a decrease in the quantity demanded. So in the real world, this quantity demanded is, I guess, somewhat of a econ term, but this is the quantity sold, if you want to think of it that way. So in the term of a business setting a price, this is the quantity sold. This might be the quantity purchased by an individual consumer. So I want you to think kind of both ways depending on the context of the question. Sometimes it can throw you. So we think about sales revenue. If we have our business cap on and we're a business, if I increase price, people aren't going to buy as much, right? The quantity sold to consumers. Or we can think about it as the quantity purchased by consumers. But either way, we're talking about the same thing. We're talking about what's going to be the demand curve. Now, one important part that I really didn't even see the author put in there, and I think because he kind of saves it for later. So I'm going to give you this one important Latin word to tack on to the end. Ceteris Paribus. Do we have any Latin speakers? Anybody know what Ceteris Paribus means? Holding all... Go ahead, Keith, you got it?
All things held constant.
Oh, nice, nice, yes. So holding all other things constant. So this relationship holds if we hold all other things constant. Things like what? Well, things like your income might be important, because if all of a sudden you double your income, price might not matter to you anymore, right? Oh, I'll pay the higher price, sure. I got a lot of money. I just won a lottery ticket or something, right? So income, the price of alternatives, which we'll spend a lot of time on in this class. So if I increase the price of Mountain Dew, I'm going to hold constant the price of Mellow Yellow, right? Mellow Yellow and Mountain Dew are substitutes. Some people would say, no way, man, you're not taking my Dew away. That's not even a close substitute. But the price of related goods can be important. So if you're a peanut butter and jelly fan, if you increase the price of peanut butter and at the same time decrease the price of jelly by the same amount, you're left the same place. If you put equal amounts of peanut butter and equal amounts of jelly on your bread, then you may be indifferent to that, right? So what we're going to do is when we make this bold assumption that you jack up price, you're going to lose people, it's holding all other things constant. All other things. So this is an economic model. Remember, it's not necessarily going to be reality that there might be other things going along. And by the way, the economist knows that. But we're creating this artificial environment so that we can analyze things. That's one of our assumptions. Just like we make assumptions on some of these problems, that's what we're assuming here. Okay. Question, let me pause there for a sec. Got that part? What does this look like? Graphing goggles. Quantity on the horizontal axis. Price on the vertical axis, but also we will a lot of times just write a dollar sign here. We're just measuring dollars. If we're looking at the demand curve, we're specifically honing into price and quantity. And so what does this sucker look like according to the law of demand? Is it a flat line? Is it upward sloping? Is it downward sloping? Downward sloping, right? So this is a negative relationship between two variables. Price goes up, quantity goes down. If price goes down, what happens to quantity? It goes up. So it goes in both directions. So these two variables are negatively correlated with each other, right? So a negative relationship. That negativeness is captured graphically with a downward sloping demand curve. Okay, so if the price of a good, give me a good, any good. First thing that comes to mind. Name it, go. Frosties, okay. Now is this Wendy's Frosty?
Yeah.
Okay. Is there any other kind, right? Okay, what do they run? What do they run?
What size do you want?
What do you think?
Well, large is
$2.97,
$2.97.
got it. So at $2.97, what do you speculate, Lizzie, since you're a fan, what do you speculate, Wendy's in town here, how many of those they sell in a day at $2.97? Huh?
To me or everyone?
To everyone. To all of the Ottawa market. Just, I know we're just guessing, but just having fun. What do you think the Wendy's would sell on a given day at their $2.97 price of these larges?
35.
35. Okay, we're gonna run with Lizzie's. I can sense an expert here. So 35. So at a price of $2.97, we have a point on the demand curve. If we actually observe sales of 35, then we have one single point, one data point on the demand curve for that day, for that day's sales. Now, what could cause it to change? County fair is coming to town. Maybe a bunch of people from the outside are coming. Again, that's Ceteris Paribus. We're changing something, right? But there's an influx of people for the county fair, and maybe there's an increase in demand, which later we'll talk more about this next week, will be a shift to the right of the demand curve. And that means Wendy's is going to now sell 86. Right? At $2.97, the demand curve shifted, and now they're going to sell more. But that's a shift. That's not what we're doing here. The law of demand now talks about price. If they lowered their price, presumably they'd sell more. If they raised their price, they'd sell less. The law of demand. Okay, questions there? Okay. Let's see. How complicated do we want to get yet? So this chapter really focuses on a different concept called elasticity. Now, before we get there, what is the value of the smoothie? Let me go back to Lizzie. Did you have one today?
You didn't have one.
You did. And what was its value to you?
Delicious.
Okay, that's good. Scrumptious.
$2.87.
What was it? Yeah,
$2.97.
I want you to value it. What was it worth to you?
Where's the fashion? Like $5. $5. $1 million.
How much enjoyment? I really want you to think about this for a second. What kind of, if you were to put a price tag, you remember how you were craving it, right? Before you went, and you're like, I'm gonna make
I'm craving it right now.
I'm gonna make a special trip. I'm gonna make a special trip over to Wendy's. I want you to value that experience. Give me a value. What was it worth to you? I want you to kind of think, what from the human experience, the scrumptiousness, the coolness on your tongue, what was it worth to you?
Does that go back to like what I would have paid for it?
Yep.
Probably paid $5.
Okay, so $5. Let's just roll with that. The point is that value is subjective, right? What it's worth to her is not the price that the company put on it. That just showed her willingness to enter the market at that point, right? Little did they know, Wendy's could have jacked it up on her a little bit. They didn't have their pricing scheme the way they have it run with menu pricing, and it's pretty well known that they have it there. An alternative could be that we just sell Frosties, come on in, make us an offer. Have you ever heard of pricing schemes like that, where they say to make an offer? Yeah, they're actually out there. We don't see it at fast food very often. But garage sale, right? Yeah, make an offer. There's nothing even priced. Well, what's it worth to you? I start low in those circumstances. So that is called consumer surplus in economics, and a very important concept to separate price from value. Value is subjective. Does your value of the Frosties change from day to day?
Yep.
Sure. It's not always $5. You might be extra craving one. You haven't had one for a month, and
That would never happen.
maybe you were trying to watch the Frosties for a while and then you gave up on that. Whatever the case is, that can possibly change. And by the way, you are correct that values for an individual tend to be pretty consistent. So we'll get into behavioral economics. And what we've learned over time is that our behavior as humans is not really erratic. Like, one day I value the Frosty at $35. The next day, 50 cents. Right? If your number was $5, it probably tends to be $5. That's why you like going there, because $2.97 is cheap for you, right? So your value, although it's subjective, tends to stay relatively stable, which is good for Wendy's and good for other businesses, that consumers' preferences are relatively stable because it makes it a lot easier to do business, right? It makes them able to make predictions because they know that there's a certain amount of Lizzies that are going to come through the door week in and week out. And then there's other people that come through the door week in and week out. And that's where they came up with this $2.97. Because if they priced it at $5, of course, we know now that they would only be selling 20. Right? They would like to be selling more because that might lead to more profit down the road. But that brings into the other part of the equation that we haven't talked about. If Wendy's is out to make a profit, what is that equation? See how I like to pin you down? That's one that should be like, blah, blah, blah. Times quantity, that's one way to characterize it, yeah. I'd probably want to right, but it's close. Price times quantity is part of it. What is price times quantity? I like to keep this just simple. What's price times quantity? What's that equal to? What's that variable? I sold 35 Frosties at $3 a piece. Revenue. Total revenue, that's half the equation, minus total cost. Now, what Lizzie said was close but not really correct. You'd actually miss it. I know, but the book had, depending on the type of question, should have a little bit more to it. So when the book gave you that, there's probably some other context to it. So here's what you want to think about of what type of cost that was, if you write it that way. I also gave you another formula on cost with that big long thing. How do we make an average cost per unit? Total cost, go ahead.
Total cost divided by quantity.
Divided by quantity, good. So we can rewrite this as price times quantity minus average total cost times quantity, which brings us to Lizzie's expression of it. Price minus average total cost times quantity is the real correct way of saying that. Sometimes we might be able to be loose with it, but there's a big difference between total cost, total fixed cost, total variable cost, average variable cost, average fixed cost. So there's lots of different types of cost. Marginal cost. So this is the expression for the profit equation. So it is good to know both of those because you might use them in different ways, different applications. All right, so this deals with, my point with all that is when we look at the demand curve and we think about pricing, we're only dealing with half the equation. We're only dealing with the revenue side. The objective of the firm is not to maximize revenue, it's there to maximize profit. Big difference. Okay, but this section especially, we are going to focus in on this demand curve and think about its various components. So the next thing we need to look at is the elasticity of demand. So the elasticity of demand, and just to be consistent with the text here, I think they call it the price elasticity. Different books call it slightly different. Yeah, price elasticity, yeah. So this is the price elasticity of demand. This is the symbol that I'll use for it for shorthand, kind of a little signal with a subscript D. So the price elasticity of demand. This is a number that shows the responsiveness of quantity demanded to a price change. A number that shows the responsiveness of quantity demanded to a price change. All right, so I'm just going to round up your 297 here to 3, just to keep things easy. So if we go from $3 to $5, we've had a price increase, and the response was a loss of 15 units. Right? So we lost 15 units. You can see how it's kind of an active measure. This is the slope of the demand curve. Rise over run, we're rising $2, we're falling 15. Elasticity is not a slope. It's related to the slope, but it's not a slope. And it is the ratio of the percentage changes. So the formula for this elasticity number is the percentage change in quantity demanded divided by the percentage change in price. So this is my notation with a little triangle. Percentage change in quantity demanded divided by the percentage change in price. Now, to let's see, I don't know if I want to use these numbers or not. If somebody increased the price from $3 to $6, what would be the percentage increase in price if it doubles? What would you say is the percentage increase in price from 3 to 6? 50? 100? 100%, right? It's 100. So you take the price is 3, we're going to take 100% of it and mark it up to 6. Now, what if I move the opposite direction and I take $3 off? I have a sale of a $6 price tag and I take $3 off of it. When you go to the store, what are they advertising as the percent off? 50%. Isn't that weird? Then we go from 3% or $3 to $6 was a 100% increase, but from 6 to 3, the same amount of money was a 50% decrease. So that we have for the elasticity demand, because when we're talking about the demand curve, I didn't want to use 3 to 5 because it gets conceptually in your head a little bit different. We want the percentage increase up to be equal to the percentage increase down, and so we take the average of the two. If we go through the whole formula for the percentage change, you might remember it's the new number minus the old number divided by the old number times 100 to shift the decimal place over a couple spots. So it's the new number minus the old number divided by the old number. That's why we get that 100%, 50% with the 3 and the 6 example. So to correct for that, we're going to use the average of the two. By dividing by a 4 each time, notice we get the new number minus the old number. 5 minus 3 is 2. Divided by 4 gives me 2 divided by 4 is 50%. If I go up, the new number, let's see, was I here? New number minus the old number, 3 minus 5 is a negative 2. Divided by 4, 2 divided by 4, 50%. So we kind of evened it out by using the average number rather than the old number. So it's a slight modification of the traditional percentage change thing that you do. So let's write that out so that we're just clear if this becomes foggy later when you're doing some problems. So if we take the, I'm going to use a little bit different terminology here. Qn for the new, I'll even write out new. The new number, Q new number minus the Q old number divided by the average quantity. All of that divided by the same modification for the price, the new price minus the old price divided by the average price. And that's the way we're going to calculate this number.
What's the Q new minus Q old over what?
Over Q av, average,
Oh, average.
the average quantity. And so we're going to do that for each one. Now your textbook gives you a short definition. I'm going to skip the detail here, but to calculate the average, 5 plus 3 is 8. 8 divided by 2 is 4, right? That's how we calculate the average. I'll just let you guys do that mentally on your own. But if you put that into this formula and make it even a little bit bigger monster, and then collapse it all down, it gives you the formula that's in your book, which is this. Q1, which is kind of our Q new, if you will. I don't know if I should screw you up or not. I'm going to put the book one in here. Q1 minus Q2 divided by Q1 plus Q2. All of that, and they lay it out all in one line, divided by P1 minus P2 divided by P1 plus P2. If you guys want to do a little mathematical proof, it just all is derived from this formula, but that's the way they give it to you in the textbook. Okay, well let's do it. Here's our problem. It doesn't matter which one's Q1 or Q2, as long as you're consistent. Remember, in fact, let me just give it to you. Let's say this is P1 and this is P2. This is Q1, which correlates with P1. So this is Q1 is 20, Q2 is 35. Everybody pull out a calculator and start chugging away. First one with the right answer gets an extra credit point tonight. So shout out your answer as soon as you get it. Brave, as soon as you get an answer, shout it, shout it, shout it. 160. If you didn't catch on to this, I haven't calculated this ahead of time, so I have no idea if that's the right answer. So we're going to play a little, who's the second answer? First one with the correct answer, so it's not over yet, folks. Tell me whatever your answer is. Did you get one, Shanita?
No, right.
I know, that's okay. Negative 1.08, okay? I'm just going to write them down. You guys tell me what you got. See if we can start to have consensus. Muhammad's got the old watch calculator. Well, I haven't seen that. Is it a full keyboard? Oh, you got it. Is that like a Google watch or something fancy? Or? Okay. You got 1.08 again?
Minus.
Okay, so Shanita's our Is anybody else getting a different answer? Are you getting that?
I got 0.27.
0.27. Okay, so one thing is I like the negative sign. Why? Why do I like the negative sign?
More old than you.
What's that?
There's more old than you.
There's more old than new. Quite what I was looking for. There's less quantity and no. More price, less quantity. And if there was less price, there'd be more quantity. So when we take this Q1 minus Q2 and P1 minus P2, there's always going to be either the upstairs or the downstairs is going to be a negative number. It has to be negative because of the law of demand. Price goes up, quantity goes down, price goes down, quantity goes up. So the elasticity of demand is always negative.
Can I just throw my number out?
Yes.
Minus 2.18.
2.18 minus 2.18?
Yeah.
1.08 again. Okay.
I got minus 1.32.
Minus 1.32.
But I
Okay.
did it by hand, so.
Okay. If you did it by hand, there could be some rounding or something here. So I'm going to take majority rule. You guys can double check this later, but it sounds like we got at least 3 people with negative 1.08. All right, so we're going to run with that. You guys go back and do your own algebra on your own time. You got the formula. I trust you can do it. So let's take 1.08. If you follow all these, it'll get that. So the elasticity of demand, how we show that graphically or kind of conceptually think about it, since we use the averages of the 20 in between 20, so here we had 27.5, we say that the elasticity of demand is equal to 1.08 in absolute value. The next slippery topic I'm going to talk to you about. So here's the deal. I'm not sure which economist to write hate mail to for this, but since everybody knows they're always negative, we generally refer to them as a positive. And we just say, yeah, the price elasticity demand is 1.08, because we don't want to say negative every time. Economists are very efficient. So anytime we can get more efficient with our language, we assume everybody knows it's negative, and then we move forward and we say just 1.08. So when you write it, if you want to write it as an absolute value, this is mathematically correct to do. I also do not deduct any points if you calculate that the elasticity of demand is negative 1.08. That's fine to write it that way. So you can write it this way or that way. Those two things are mathematical equivalents. But you can't write this, right? That would be wrong. So either way is fine. But I do seriously want you to know when you see it or we talk about it, often it'll be expressed as a positive. But because we got that figured out. Now, if we have a line here and I drop down to $1, what is this number? What's the quantity? Let's call it Q3, I guess, or something. At $1, what's this number?
Projected.
It'll be exact because assuming this is a line, so no projections needed, 50. So slope of the line is constant. Rise over run, down 2 over 15. Down 2 over 15, so this will be 50. Okay? If we go and calculate the elasticity, what will it be? Let's do it. If you didn't get that negative 1.08, now you got a new set of numbers. Now notice what's going on here. Your P1 or your P2, I don't care what you do here to be consistent, but you got 3 minus 1, you've got 35 minus 50, however you're calculating it. Go ahead and calculate that. First person with the correct answer Shanita got the first one. We'll get another extra credit point. We'll see if we can get you guys comfortable with it.
Shanita, value has to be recalculated.
Why?
No, I was just being silly.
Oh.
I'm convinced that is 2.18.
Oh, I see. Okay. All right, I got my extra credit pen out. I haven't heard any answers yet. Shanita's got +1 column tonight. Can she go for 2?
I got 0.35.
0.35.
Absolute value.
Absolute value, 0.35. Got it. Okay, so what do we got? 50 minus 35 is 15, divided by the average of those two is 42.5. All over P1 minus P2, we get a -2 over the average of the two is $1.50. And you got the same thing? Everybody good? All right, so we have a winner, 0.35. Elasticity at this point was 0.35. So did the slope change? No, but the elasticity did, so that's an important takeaway here. So the elasticity changes at every point along the demand curve. The elasticity of demand changes at every point along the demand curve.
I have a quick question.
Yeah.
When you wrote the two different equations, what the book said, you said it was Q1 minus Q2 over where you had put Q average, but Q1 plus Q2.
Right.
Are those?
So if you go through all
this up, or
no,
does she
all,
make different things?
the twos. So let me talk to you after class.
Okay.
It all breaks down.
Okay.
Yeah. So there's a little proof here that you can get to this. The twos end up canceling for the average.
Okay.
So bear with me now. We'll just go with the formula and we'll talk after class. Okay. So 0.35, is that more responsive or less responsive? The price elasticity of demand is a number. By the way, it's a unitless number, just an extra bonus thing to add in there. There are no units. It's just the ratio of two percentages. So it's not, this isn't in dollars. It's not $0.35. It's not 0.35 umbrellas or Mountain Dews or whatever. It's a unitless number. There's no units to it. A unitless number that shows the responsiveness of quantity demanded to. So my question is this more responsive or less responsive compared to 1.08? Which one shows a bigger responsiveness on the part of the consumer? 0.35? And what's your gut telling you on that? Why is that?
Because at $1 you're going to sell more.
Okay, you're going to sell more. Now, let's back up on the story. What I really did is I dropped my price $2 and I increased 15 units. And I did the exact same thing up here. I dropped my price $2 and I increased 15 units. But there's something goofy going on with the percentage changes, right? Because this number ended up being different. So, which one shows a greater responsiveness? Is it 0.35? Is a price change from, let me go up for a moment. Is a price change from $1 to $3, is that a big increase percentage-wise? Yeah, it's huge, right? 300% if we were doing the old-fashioned way, right? $2 would be doubling it. So this is a huge percentage increase. And what was the percentage decrease in sales? Well, it was a big number minus another bigger number divided by the average. So if we're over here with big numbers, let's go down to 100 units, and I go to 85. I'm kind of off the charts here. Is this percentage change a bigger number or a smaller number relative to these? It's smaller, right? So as we move along the demand curve, the interesting thing that's going on is that the percentage changes in quantities are getting big, the percentage change in prices are getting small, and vice versa heading this way. So the thing that's kind of odd here is you need to really think about this part of the formula. So yes, we kind of got lost in some math and stuff, but you guys have to have this one memorized too. Hint, hint. So this one is just as important. And it also gives you a nice interpretation to give to the CEO of what that 1.08 means, or the 0.35. So if the economist estimated 1.08, so the elasticity of demand equals 1.08, and the boss says, whoa, slow down, talk to me in real language. What does that mean? Oh, well, here's the thing. You can always mathematical maneuver, remember from 5th grade? Take any number and divide it by 1. Why did I do that? Because now we can tell a nice little story to the CEO. Boss, a 1% increase in price will lead to a 1.08% decrease in quantity. A 1% jump in price is going to cut sales by 1.08%. And so we can always get a nice interpretation of the elasticity by using that. So, interpretation. A 1% increase in price will lead to a 1.08% decrease. There's the law of demand kicking in, right? Increase one, decrease the other. A 1.08% decrease in sales. Let's just use that term. Quantity sold. Sales, I'll put sales or quantity demanded. That's what our formula was doing. But if we have our boss hat on, the boss is just thinking in terms of, well, what am I going to sell? If we raise tuition at Ottawa University, how many students are we going to lose? Right? Law of demand. If you jack tuition by 10%, economists have estimated that you're going to lose 20% students, or whatever. But we go back to that elasticity to look at the responsiveness of quantity demanded to a price change. Whew! Okay, questions on that? Before we go to break, I want to plant a little seed that we'll talk about when we come back. Well, actually, before we do that, then look at this, that hopefully this will kind of help with the responsiveness. If I interpret this number, a 1% increase in price will lead to a 0.35%, less than a 1% decrease in sales, right? So consumers are not as responsive at a 0.35 compared to a 1.08. So we say that demand is more elastic here. The bigger number is more elastic. And I'm gonna lay this all out when we come back from break. But I just wanted to plant that seed to be thinking about the number. And actually I was gonna do one more thing, but we're gonna take a break instead. hit that when we come back.